So just go over a small set of questions here related to just general discrete random variables. This first one, it should be pretty easy. This actually looks like an example that we saw in class where we have 4 different mean bonus amounts. So 10, 6, 3, 0 million, and they're different probabilities of them occurring, right? So how would we find this mean bonus amount? Well, one thing we don't want to do is ignore these probabilities. Because we just simply add these 4 values up and divide by 4 like we would a typical mean, we're not going to get the correct answer, right? So the way in which we found a weighted mean, right, was very similar to what we do with these discrete random variables. So here's our weighted mean equations, but let's go over here. We actually have a discrete random variable where our probabilities are weights, so that denominator, the sum of the weights, just became 1. It made our life a little easier. So all we do to find the mean there is go through each value for x and multiply it by the probability we see that value for x, and then add them all up. So here, it'll be as simple as take that 10 million, multiply it by 1.5, add to that 6 million times the probability that we see 6 million, which is 0.25, add to that the next possible outcome, 3 million times the probability we see 3 million, and then add to that 0 times the probability we see 0. If we do that, we should get 4.2 million. Okay? So when we see something with probabilities here, we should be thinking this is a discrete random variable. These are the likelihood that we see these different outcomes. And here's our mean and our variance for our 2 equations for the discrete random variables. The next question asks for the standard deviation of these bonus amounts. So one thing I'll typically do on these exams is, look, if you somehow calculated the mean incorrectly, you made a mistake in your calculator, or you just got it wrong, then you're definitely going to get the standard deviation or the variance wrong, because we need that mean to find the variance. Okay? So if we look here, first of all, we can rule one of these answers out pretty quickly, right? The variance, or the standard deviation, will always be positive. So right away we know B doesn't make any sense for us. So what we're going to do to find the standard deviation, we first have to find the variance, which is go through every single possible outcome, subtract the mean, square that deviation, and then multiply that by the probability that that outcome for x occurred. So we'd start out, take that very first outcome of 10 million. Here I've given you that assumed true mean, so we'll subtract 5 million, square that deviation, and then multiply that by, and here my order of operations probably won't look correct, but I don't want to throw in a ton of parentheses, so I guess I could put this at the beginning to make it a little easier. I'll multiply that deviation by the probability that it occurs. I'll then add to that the next possible outcome, right? The probability it occurs is 0.25. Multiply that by that value of 6 million's deviation from the mean, which I was told is 5 million, right? And I then just do this for every single possible outcome that I have. So I'll type those out here. Hopefully that, I've already kind of explained the process. It shouldn't be too bad. Right? And that will give me my variance, right? There's no denominator because the sum of the probabilities is 1. So once I find this, right, if I want the standard deviation, I still have one more step, right? So that one more step is taking the square root of whatever this is. So if I enter this in my calculator, which I'll do here, plus 0.25 plus 0.4 times 2 squared plus 0.2 times. Oh, also, sorry, I made a typo here. I accidentally hit period instead of a minus, right? I'm looking for the deviation squared there. So this should be 10.6. If we want the standard deviation, we then have to take the square root of that. So go up here, add in a square root. The square root of 10.6 should be at 3.25. Okay? Now the last question should be hopefully really easy. And I can just enter a bunch here so we can have this all on the same page. So let's say at 16, what's the probability that a trader gets at least $3 million? So on the exam, I might not have written this part in there for you, I may expect you to know on your own, but if I want the probability at least 3 million, that's 3 million or higher, right? So when I have a discrete random variable, where here's my probability mass function, it just tells me the probability of these different outcomes, it's as simple as what fits this criteria, and then add the probability of each one of those outcomes up. So 3 million or higher, I'll take the probability of 3 million, add that to the probability of 6, and then add that to the probability of 10. So it'd really just be adding up these three values. So 0.4 plus 0.25 plus 0.15, which should give me 0.8. Right? So the only kind of tricky thing on here would be is really pay attention to that equality sign. Right? If I would have said, what's the probability that you get a mean bonus of more than 3 million, right? Then there's no longer an equality here, and the only outcomes that would fit that would be 6 or 10, so you'd only be adding up those two probabilities. So that's really the only wrinkle you could see in that type of a question.